Assalamu alaikum dear student. The topic of today's session is compression. As you can see in the GIF image that what is the meaning of compression. So basically it's reduction in file size. And why do we need to reduce the file size? There are basic 3 to 4 reasons. First reason is that whenever we are compressing a file, we need more storage space, and yes, a compressed file take less storage space, right? We can save more files, more compressed file in our drive. Second reason, usually we need to upload our files over the internet or stream over the internet, so it is taking less time for transferring data from the computer or to the computer. The third reason that we need the compression is that definitely it's saving the time in terms of processing. Computer processing time saved when you are transferring small sized file. So let's discuss how many types of compressions are available in computers. So basically there are two types of compression. One is known as lossy compression and the other one is known as lossless compression. Lossy compression. So as its name indicates that lossy means that we lost some data while compressing the file. And yes, we have two types of files. One is your original file and the other is your compressed file. So original file is compressed and then you can acquire a compressed file. Definitely the size of original file would be greater than the one that is being compressed. So in lossy compression, what we usually do, we use some compression algorithms. And what these compression algorithms are doing for us, these are finding the unnecessary and redundant data in the file. For example, if I am talking about audio files, yes, there are several types of sounds that are not audible by human ear. So what do? We usually reduce them. Same and Same in the case of image files as well. There are few colors or many colors that cannot be seen by human eye. So during the process of compression, we need to remove that bits which are including such type of data. So that is known as lossy compression. And the important thing about lossy compression is that if you want to regenerate the original file from the compressed file, so my answer is no. Once the file has been compressed, you cannot acquire original file out of it. Now we are talking about lossless compression. Lossless compression is a reduction technique or file reduction technique in which we reduce the file size by implementing some compression algorithm in the way that we are not losing any data. So, common method that can be used to do this is by finding repeating data in the file and grouping this data together. We will solve one of such kind of example onto our next slide. But yes, in your course there is one algorithm included that is known as run length encoding algorithm. Yes, the same practice we do in it, that we groups together repeating pattern and index them. So let's proceed how we are going to implement such type of compression onto our data. Lossless compression is very ideal choice in case of text file. So that's why I have chosen an example from text file. For example, we have this text: when it is snowing heavenly, look outside, it is snowing heavenly. So this is our text. So what do we need to do? We need to index. First of all, I have already counted the number of characters into this data. So there are 62 characters into this data. And for each character, we require 1 byte. So there are 62 bytes to store this whole text. Now we need to implement some compression algorithm onto it. So what I am doing, I am going to position each word. So there are 13 words in this example. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So what do I need to do? I usually construct a lookup table. Now what is this lookup table? What I am doing in this case that I am storing the position and then how many time this word is occurring in that specific text. So let's start. For example, when is one of the word, and yes, it is at location 1. Then we have it. It is occurring 2 times, location 2, and yes, location number 10. So I'm going to write it like this. And for is, yes, you can see here it is on location number 3 and location number 11, etc. etc. So a complete lookup table, I can show it to you. Here you can see here, for this text, we have this complete lookup table. Yes, here it is. So quite clear that this is our lookup table, and yes, uh, you can practice it by yourself by pausing my video and check if you are able to construct the rest of the elements of a lookup table. For example, if I'm saying outside, outside is on position number 7 and position number 9. Okay, now our major focus is to calculate the file size, that if I'm implementing such type of algorithm, what is the effect on this size of 62 bytes? So let's start. I am saying when is a word, I am needing 4 bytes for it. For it, I am needing 2 bytes. For is, I am needing 2 bytes. So how many letters are here? 1, 2, 3, 4, 5, 6, 7. 7 bytes is required for storing snowing. 1, 2, 3, 4, 5, 6, 7. 7 we need here. Then 4. 1, 2, 3, 4, 5, 6, 7. 7 characters. 7 bytes I require for these number of characters. So altogether it makes 6, 8, 15, 22, 26, 7 and 33. So 33 bytes are required for storing the text. And yes, we need to store the position as well. So for storing the position, I require 2 bytes for these positions, 3 bytes for these position, 2 bytes for these position, 2 bytes, and 2 bytes, 2 positions, 2 bytes, 2 positions, 2 bytes. So altogether it's making 1, 2, 4, 8, 6, 10, 12, 13. So 46 bytes. After applying such kind of compression, I can reduce the file size to 46 bytes. And if I calculate it in form of percentage, it's 26%. It's quite a good amount for a lossless compression. And the important thing about the lossless compression is that we would be able to construct the original file from the compressed file. So this is the this is the size of compressed file, and by looking into the lookup table, we can reconstruct this 62 byte file again. Hopefully you got the idea of lossless compression. So one of the questions that I have taken from the past paper. So what this question is all about? This question is about if I am storing a text file, this is the text file, how am I going to implement lossless compression on it? So keep this thing in mind that it is writing about how, and it carries 5 marks. So we need to write 5 points in this description. So definitely for lossless compression, the important thing that we need to do is, first of all, we will identify first type of algorithms we are implementing on it. Any lossless algorithm. And what we usually do in lossless algorithm, we are going to count the number of occurrences, right? And then index, that how many times this specific text is being repeated, and we are going to count the index, we are going to count the position, and then we are going to write it in the form of encoded algorithm. So let's see what this answer is. So we are going to answer this question somewhat like this. Thank you very much. Keep watching my video and subscribe my channel.